anaconda, 28 feet of muscle, 500 pounds of pure ambush predator. The kind of animal that makes wildlife documentarians nervous. It is, by any measure, a monster. Now double it. Now add 1,000 pounds. Now put it in a world so hot, so wet, so relentlessly alive that even that creature, that thing, wasn't the top of the food chain. It was just normal. That animal existed. It was real. And the closer scientists look at it, the weirder it gets. Not just in size, in everything. How it lived, what it tells us about our planet, and what its disappearance means for the world we live in right now. This is Titanoboa, and nothing about it is what you expect. It started, as so many great discoveries do, with someone holding something they couldn't explain. The year was 2009. A team of paleontologists was working a site in northern Colombia, a place called Cerrejón, one of the largest open-pit coal mines on Earth. For years, researchers had been quietly pulling extraordinary things from that rock. Ancient turtles, early crocodilians, plant fossils so perfectly preserved you could trace the veins in their leaves. But then one researcher lifted a chunk of rock, and embedded in it was a vertebra unlike anything in the collection. It was massive, dense, curved in a way that was deeply, unmistakably familiar, and yet completely wrong for anything they expected to find there. They ran comparisons: modern pythons, anacondas, ancient constrictors from other sites. The numbers kept coming back the same. If this vertebra belonged to a snake, and the geometry said it did, then that snake was somewhere between 13 and 15 meters long. Possibly more. They brought in more specialists. They argued. They ran the scaling models again. The models didn't change. What they were holding was a piece of the largest snake ever to have lived on this planet. An animal so far beyond the limits of modern biology that its existence forced scientists to reconsider what limits even meant. They named it Titanoboa cerrejonensis, Titanic boa from Cerrejón. And the questions started immediately. Here's what strikes you when you actually sit with the data on Titanoboa. It's not just the size that's strange, it's that the size is the least strange thing. Start with the weight. Estimates put Titanoboa at somewhere between 900 and 1,100 kilograms. That's not a big snake. That's a small car. A creature that heavy on land would have its own organs pressing against each other under its own body mass. Breathing would be labored. Movement would be exhausting. Its heart would be working, which means Titanoboa isn't just a fossil. It's a thermometer. A biologist has been, and could be again. To understand Titanoboa, you have to understand the Paleocene epoch. Not just as a time period, as a sensory experience. It is roughly 60 million years ago. The dinosaurs have been gone for 5 or 6 million years. Earth is still processing that loss. Ecosystems rebuilding, niches emptying and refilling, evolution running fast to fill the gaps. Mammals exist, but they are small, cautious, opportunistic. The real inheritors of the post-dinosaur world, at least in the tropics, are reptiles, and the tropics themselves are unlike anything alive today. There is no dry season at Cerrejón. Rain falls constantly. The canopy is so thick that the forest floor lives in permanent green twilight. Rivers overflow their banks and stay that way. The boundary between land and water is a suggestion, not a fact. And over all of it hangs a heat so total, so unrelenting, that it seeps into the rock itself. This is the world the Cerrejón fossil site preserves.